Hello everyone, welcome to GATE lecture series. Myself N.Rajavinu, Electrical and Electronics Department from SA Engineering College. I am going to take superposition theorem. So this is our GATE syllabus. So in this syllabus I am going to take superposition theorem. Definition for the superposition theorem. The superposition theorem states that any linear circuit which consists of multiple sources that should be equal to the multiple sources response of the element is equal to the algebraic sum of responses caused by the source acting alone. So the steps for solving the network by superposition theorem. So initially we have the circuit. So the circuit diagram A. Consider the circuit diagram A. We have to follow the different kinds of steps. Step number 1. So we have two energy sources, E1 as well as E2 is the energy sources. The capital R1 is indicate the external resistance and the small r1 is indicate the internal resistance. The internal resistance which is built in the sources. So step 1. Take only one independent source of voltage or current and deactivate the other sources. We have the two sources means first initially we have to keep on the one sources and remaining other sources will be deactivated. For that we have the two steps to deactivate the sources. If any voltage source present means we have to short circuit the sources, and if there is any current source means just open circuit the sources. So in this case we have the E2 is the voltage source. So just we are going to short circuit the sources. So in E2 there is no internal resistor. So we just consider the short circuit. So this is indicated by the circuit diagram B. And step number 3. The deactivator, that is activating only the sources and deactivating the other sources, we have to mark the current direction for each and every resistance. For R1 we are going to take I1 dash, and R2 we are going to dash the current direction as the I2 dash, and R3 I3 dash. Initially we take I1, I2, I3 is the current flowing through the R1, R2 and R3. Now the new current is indicated by the dash, I1 dash, I2 dash as well as I3 dash. That is indicated in the step number 3. The current I1 dash, I2 dash and I3 dash. And step number 4. E2 is the voltage source. Now we are going to keep the E2 source alone, and E1 source is we are going to deactivate it. So in this case E1 having the internal resistance R1 resistance. So we have to keep the R1 resistance. If there is, but in this case we have the R1 is the internal resistance. We have to put the R1 resistance in this circuit. And next we are going to mark the current direction, and this current direction is indicated by the double dash, I1 double dash, I2 double dash as well as I3 double dash. And step number 5, determine the current in the various section I1 double dash, I2 double dash and I3 double dash. Next step number 6, now we are going to calculate the total current in the individual resistance. Determine the net branch current, utilize the superposition theorem. That is nothing but we are going to add all the current, individual current. That is I1 is nothing but I1 dash minus I1 double dash. I2 equal to I2 dash minus I2 double dash. I3 equal to I3 dash minus I3 double dash. And step number 7. If the current obtained by the each branch is the same direction, then add them. In the opposite direction means we have to subtract. Now we are going to discuss about the application of this superposition theorem. So this theorem we can apply, that is we can calculate the current in any circuit. Wherever the Ohm's law apply, we can apply this circuit. So this theorem is used to determine the current in any branch of the network containing 2 or more voltage source or current source or both sources are present. And limitations of superposition theorem. So this method is only applicable for linear circuit. This circuit is only applicable for linear circuit and it is only applicable with the several sources. If there is any individual sources means we can't apply this theorem. As well as this theorem should not used to calculate the power because power is not a linear. That's why we can't calculate the power in this circuit. So now this is the gate problem. And find the voltage across the 3 ohm resistor using superposition theorem for the circuit shown in figure. So this is the given problem. In this given problem, we are going to calculate the voltage across the 3 ohm resistor. In this problem, they are not asking the current, but they are asking the voltage. So what is the voltage across the 3 ohm resistor? So this is the given problem. So look at the diagram and we have the 3 different kind of sources. One is the 6 volt voltage sources, another one is the 18 volt source and third one is the 2 amps current source. So the 2 voltage sources as well as 2 amps is the current sources. So we have to calculate consider only 6 voltage source. So keep the 6 voltage source alone and remaining 2 sources should be deactivate. So the first step, if there is any voltage source means that should be short circuited. If there is any current source means that is open circuited. So consider only 6 volt voltage source, short circuit the 18 voltage and open circuit the 2 amps current circuit and redraw the diagram. So keep only 6 volt voltage source. Now we are going to calculate the voltage across this 3 ohm resistor. Okay, whenever the voltage source should be short circuited, this 2 ohm as well as 6 ohm should be connected in parallel. One end of the 2 ohm connected to 6 ohm and another end of the 6 ohm is connected to 2 ohm. So these 6 ohm as well as 2 ohm resistor connected in parallel. According to the parallel conversion, the 2 resistors are connected in parallel means multiply the resistance divided by the sum of the resistance. So we get 2 into 6 divided by 2 plus 6. 2 into 6 is nothing but 12. 2 plus 6 is nothing but 8. We get 1.5. So the value of these 2 resistors should be simplified and put the value 1.5 ohm. That should be the answer. Now this 1 ohm as well as the 3 ohm both are connected in series across 6 volt voltage source. Now we are going to calculate the voltage across the 3 ohm. Let's take V1. V1 is nothing but voltage across the 3 ohm for 6 voltage source. So according to the voltage division technique, total voltage into the particular resistance divided by the sum of the resistance. So V1 equal to the total voltage is given by 6 voltage into, we are going to calculate the 3 ohm resistor, voltage across the 3 ohm resistor. So 6 into 3 divided by sum of the resistor, 3 plus 1.5. So 6 into 3, 18 divided by 4.5, we are getting 4 voltage. Now only 6 volt, for keeping the 6 volt, we are getting the voltage across the V1 is the 4 voltage. So this is the first V1 value. V1 equal to 41 while keeping the 6 voltage source. Next, by considering the 18 voltage supply, deactivate the other two sources. One is the 6 voltage source, another one is the 2 amps current 2 amps. So the 6 voltage is short circuited and 2 amps is the open circuited. So we are going to keep the 18 voltage as the main source and remaining 2 are the deactivated source. One is short circuited, another one is the open circuited. 2 amps is open circuited and 6 voltage is the short circuited. So we have the diagram like this. So in this diagram, this 2 ohm as well as 3 ohm connected in parallel. This 2 ohm as well as 3 ohm connected in parallel with 6 ohm resistor. The total voltage is 18 ohm. The circuit should be redraw like this. So this is the 18 voltage. And now the 2 ohm as well as 3 ohm connected in parallel. By parallel, 2 into 3 divided by 2 plus 3. That is already we derived in the last case. So we get the 1.2 ohm answer. So 2 into 3 divided by 2 plus 3, 6 by 5 equal to 1.2. Now we have to redraw the circuit. 6 ohm and 1.2 ohm with the 18 voltage source. This 6 ohm as well as 1.2 should be connected in series. So total we are having in series, just add the 2 resistance value. 6 plus 1.2 equal to 7.2 ohm. So 18 source directly connected with the 7.2 ohm. So we are going to calculate the current in the circuit. So the current I equal to, we know the Ohm's law, V by R. I equal to V 18 volt divided by 7.2. So the answer is 2.5 amps. Now we are just calculating the current in the circuit, not the voltage. And again, we are calculate the voltage across the 3 ohm resistors. So already we derived the current I equal to 2.5. Let's take I equal to 2.5 is the total current. Okay, we are going to calculate the voltage across the 3 ohm resistor. So V equal to I into R. By Ohm's law, V equal to I into R. So now we are going to calculate the what is the current flowing through the 3 ohm resistor. How much amount of current flowing through the 3 ohm resistor? We have the total resistor. So by using the current division technique, what is current division technique? So the current division technique is nothing but the total current I into opposite resistance divided by sum of the resistance. So we are going to calculate the current flowing through the 3 ohm resistor. So I equal to 2.5 is the total current into, so what is the opposite resistance for 3 ohm? 2 ohm. So 2 divided by total resistance 2 plus 3. So 5 divided by 5. We are getting the 1 amps current. Okay. So we are going to calculate we found the current flowing through the 3 ohm is the 1 amps. Now by Ohm's law, voltage across the 3 ohm resistor. Let's take this is V2. Already we derived V1. This is the second source. So let's take V2 equal to 1 into 3. That is current is equal to 1. Voltage is equal to 3. So we get 3 voltage. Okay, so the particular V2 equal to 1 into 3. So V2 equal to 3 volt. This is for the second source. And third source is the 2 amps current source. So far we are going to keep the 2 amps current source and remaining 2 sources are deactivated. The remaining 18 volt as well as 6 volt is the voltage source. So just short circuit the source. 18 voltage as well as 6 voltage is the short circuit voltage. And again we are going to redraw the circuit. 6 ohm, 2 ohm, 3 ohm both are connected in parallel. This 2 and this 6 connected in parallel, and this combination is also connected with 3 ohm is the parallel circuit with 2 amps. So the 3 resistance are connected in parallel. Already we derived 6 and 2 parallel means we get 1.5 ohms. This 1.5 as well as 3 ohms connected in again parallel. So 1.5 as well as 3 both are connected in parallel with 2 amps. Again we are going to calculate the current flowing through the 3 ohm resistance, because we are going to find the voltage across the 3 ohm resistor. By simply we can go for the current division rule. Total current 2 amps. So I3 equal to, that is current flowing through the 3 ohms is equal to I3 equal to total current 2. What is the opposite resistance for 3? That is nothing but 1.5. So 2 into 1.5 divided by 3 plus 1.5, that is total resistance. 3 plus 1.5. So 2 into 1.5 is nothing but 3. 3 plus 1.5 equal to 4.5. We are getting 0.66 amps. This is the current flowing through the 3 ohm resistors. By using Ohm's law, what is the voltage across the 3 ohm resistor? 0.66 into 3. So we get the minus sign because we are putting in the opposite direction. That's why we are using here minus. So we are getting minus 2 volt. This minus 2 volt is nothing but third source voltage. Third source voltage is nothing but V3. So the overall voltage by superposition theorem, multiple sources in the circuit is equal to algebraic sum of the individual circuit acting alone. So the total voltage V equal to V1 is the single source as well as V2 is the again single source and V3 is the single source. So V1 plus V2 plus V3 equal to 4 plus 3 minus 2 equal to 5 volt. So by using superposition theorem, the voltage across the 3 volt is 5 voltage. The final answer is the 5 voltage. So thank you all. We are meeting in the next session.